Today is 181 day of the series. And the keynote speaker for today's session is with us Honorable REKHA SHARMILY Madam. So first of all, I welcome to you, Madam, for the dais.
Thank you, sir.
I welcome the Chief Organizer of the series, the Principal of Shri Kumarswami Mahavidyalaya Ausa. I welcome the colleagues from my college, IPAC Coordinator Dr. Sanjay Kale Sir, Dr. Anita Dhole Madam, Honorable Praveen Udge Sir, and heartily welcome all those dear participants. So today is one of the significant topic for presentation, that is machine learning, which is going to present Honorable REKHA Madam. She is an assistant professor at Bharath Institute of Higher Education in Chennai, Higher Education Research in Chennai, Tamil Nadu. So with this brief introduction, our request to you, Madam, please start your presentation on the topic machine learning. You are most welcome, Madam.
Thank you, sir, for welcoming me. Thank you. I thank one and all for giving a chance for me to be a part of this World Series program. I am REKHA SHARMILY and I am working as an assistant professor at Bharath University located in Chennai. My topic is Introduction to Machine Learning. Shall I share my slides, sir? Thank you, sir. Is it visible, sir?
No, Madam.
Sure, sir. Yes, sir. Is it visible, sir, now?
Yes, Madam, it's visible. Perfect. Please continue.
Thank you. Okay, so thank you, sir. So my topic is an introduction to machine learning, and the outline of my presentation are machine learning, types of machine learning, steps to solve a machine learning problem, deep learning, artificial neural networks, image classification, and convolutional neural networks. So now we are going to see how machine learning is solving a problem. So now let us consider that our problem is to identify a cat. So what is a cat is our problem. So the input image set consists of various images of cats. So these are three representation of cats. So first one was a light brown color, second cat was a dark, third one was dark brown in color. And also we have some more images like this. So these are also some of the types of cats representation. The first one here shows the occlusion type, that is only part of the cat was visible. The next one was diversity. So this is a different type of the representation of cat. Next, it was a deformed image of a cat. The last one was lighting variations. So without any lighting, a cat was represented. So like this, whatever may be the image input we are going to give to the machine learning model, it has to identify and classify it as a cat. So this is the problem we are going to solve today. So first, let's see what is machine learning. So machine learning is the subfield of computer science that gives computers the ability to learn without being explicitly programmed. So by Arthur Samuel in 1959. A computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves with experience E by Tom Mitchell in 1997. So machine learning is nothing but using data for answering questions. So here we'll be given a data set. That data set we'll be classifying or splitting into two parts. One part we are going to use for training the model, and the next part we are going to test the data. So now we'll see the types of our machine learning. So basically machine learning, we have three types. They are supervised, unsupervised, and reinforcement model. Let us see the first type. The first type was supervised model. So in supervised model, so learn through examples of which we know the desired output. So what we want to predict. So in this example, we want to predict what is a cat. So is this there is another example like is this a cat or a dog? Are these emails spam or not? Predict the market value of houses given the square meters, numbers of rooms, neighborhood, etc. So these are some of the problems which we can solve using supervised learning. Next, there are two types in supervised learning. They are classification and regression. So in classification, the output will be discrete. Like example, this may be yes or no or cat or dog. Only two classes we will be having. So output will be discrete like this. So next we have another type, that is regression. So in regression, the output was continuous. Like we'll be predicting the temperature of tomorrow. We'll be predicting the weather of tomorrow. We'll be predicting the price of a house by knowing the data, like the area of the house, the number of rooms present, the like that. So depending upon the other parameters, we can already known data, we can predict the price. So these are known as supervised learning. Next type was unsupervised learning. In unsupervised learning, there is no desired output. So we have to learn something about the data from the given data, and we have to develop latent relationships between them. So for example, I have a collection of photo and I want to put them in 20 groups. So this is an example of unsupervised learning. So, for unsupervised learning, it was useful for learning structure in data, like forming clustering or finding out hidden correlations and reduce the dimensionality. For example, the feature map is of more than 320 dimensions. Then if I want to reduce to 200, only 200, then I can use a unsupervised model. In this example, we have a cluster of data and we are going to classify it into three groups. The orange one was classified into the first cluster. The blue one is classified as the second cluster, and the green one was classified as the third cluster. So one more machine learning model was there, that was called as the reinforcement model. So here in reinforcement model, an agent interacts with an environment and watches the result of the interaction. So here the environment gives feedback via a positive or a negative reward signal. So here we will be learning like trial and error method. The very good example is online chess game playing. So that is also an example for reinforcement model. So totally we have 5 steps in machine learning model for solving a problem. The first step was data gathering, that is collecting the data from real-time sources or from online sources. So data nowadays are available everywhere. So data was collected. That was the initial step. Then the collected data was pre-processed. So for pre-processing, we'll be cleaning the data and we'll be maintaining homogeneity of the data. So next one was feature engineering. So here we'll be extracting the features of the data, whatever was given. So the features will be, using the features we can model the machine learning model. So here the making your data more useful was only done through feature engineering. Next one was the relevant algorithm selection and training. So here the algorithm was selected. For example, for classification problem means we have to select supervised learning. So for a trial and error method means we have to use reinforcement model. So like that, we have to select the corresponding algorithm and train the model with the given data. So for example, we have 100% of the data. Here 80% of the data was used for training the model. So that if I am having 100 cat images I'll be giving for training the model, so that the model will understand that this is a cat, these are the features of the cat, this will be the ear of the cat, this is the eye of the cat, this is the nose of the cat, like that it will understand. Then if I am going to give 20 more images whichever left over for testing whether it was identifying, it will be correctly predicting the output. So it will be predicting the output as cat. So that is making predictions and evaluating the model. So next one was data gathering. So data gathering can be done manually. So manually labeling for supervised learning was necessary, since for supervised learning the data will be available with labels. So the more the better. Like, so some algorithms like neural networks. So if I am using artificial neural networks, they require more number of data. So the quantity and the quality of the data dictates the model accuracy. So data pre-processing, our next step is data pre-processing. So let us consider this image. So here we have a set of large number of green apples and only one red apple. So if it was classified by a SVM or decision tree or any other classifier, the result will be biased like this. So here in what is wrong in this data is no values are missing. All the values are present here. No outliers are there, and no bad encoding is also there. So no wrongly labeled examples are also there, but only the data was biased. So we have sample of only one data. We don't have we have less samples for the red apple. That is only one red apple was provided here. So we need to fix this, and we have to remove the data and replace the next data for classification. Then only we'll be getting the correct classified output. So feature engineering. So all our inputs are represented by set of features. A feature is an individual measurable property of a phenomenon being observed. To classify a spam or email, features could be the number of words that have been changed like this. For example, here in the place of changed, so 4 was changed, A in the place of A, 4 was replaced, and in the place of E, 3 was given. So this is how now if it email was found like this, it will be classified as a spam. So similarly, language of the email. So if we are sending in English, and if I am going to get some other language like Spanish, then it will be automatically classified as a spam. Similarly, number of emojis. So if the number of emojis are large, or if any emoji was present, it will also be classified as a spam email. So for feature engineering, extract more information from existing data, not adding new data. So with good features, most algorithms can learn faster so that we can predict our output more early. So there are a number of algorithms. So in algorithm selection and training, so we have three models here, that is supervised, unsupervised, and reinforcement. So for supervised method, we have linear regression. So this will be classifying only two class. Naive Bayes, it is a multiple classifier. Support vector machines, so it can also classify multiple classes. Decision tree, so it will be classifying only two class. Random forest, it will be classifying multiple class. So we have another methods like k nearest neighbors, then neural networks. So inside neural network, we are going to see deep learning. Next, for unsupervised, we have PCA, that is principal component analysis, that is used for feature reduction of the feature map. Then we have k-means method. Then we have DB scan method. For reinforcement, we have SARSA, Lambda, and Q learning models. So algorithm selection and training. So goal of the training is making a correct prediction. So incremental improvement. So for we'll be predicting the model, we'll be finding out the fault, and we'll be adjusting the model, and again we'll be giving to the predicted model. So this will be until done to get the highest performance. So use of the metrics for evaluating performance and comparing solutions. So here hyperparameter tuning, like deciding the number of layers of the network model, everything will be done. So if you are going to perform parameter tuning, the model will be optimized. It can give higher performance. So here for making prediction, we have two phases like training phase and prediction phase. So for the training phase, we'll be giving the labels and samples into the machine learning model. So the features are extracted from the samples and these features are given to the machine learning model, and the machine learning model is trained with these features and it is given to the trained classifier. In the prediction phase, the test data is given as the input and the features of the test data are extracted by the feature extraction module, and the features are given to the trained classifier and it will give the output. It will label the output as what. So summary, so machine learning is an intelligent use of data to answer questions enabled by an exponential increase in computing power and data availability. Three types are available. They are supervised, unsupervised and reinforcement. 5 steps to every machine learning solution, that is data gathering, data pre-processing, feature engineering, algorithm selection and training and making predictions. So now we are going to see how we are going to classify it and find out it as a cat by using a deep learning model. So deep learning is a type of artificial neural network and a subpart of our machine learning. So here we will be using neural networks. It is based on neural networks. So artificial neural network, the first model of the artificial neural networks was proposed in 1943. So here we have given two models. The first one was the basic perceptron model. So here I am giving 4 input and each input was having a corresponding weight. So for here I'm giving 4 inputs like x1, x2, x3, x4 and corresponding weights are w1, w2, w3 and w4. Now I'm going to sum all the weights and then I'm going to give it to an activation function. So if the sum was above or equal to the activation function, then only output will be received. So here we'll be having a threshold value. So if our sum value was above the threshold value, then only activation will be done by the activation function. The next model will be having 3 layers. That is, first layer will be the input layer and the last will be the output layer. Between the input layer and the output layer, the hidden layer was present. So all the activation will be done in the hidden layer. So image classification with deep neural networks. So all the images will be, when they are represented digitally, they will be represented as a matrix of numbers. So for example, if I am going to use a gray image, so in gray level image, we'll be having only one matrix. So here I am using a colored image of a cat. So here I am going to have 3 matrices of 3 channel representation, that is the red channel, the green channel and the blue channel. So I am having here a feature set of 3 channels. Now let's see how convolution takes place. So convolution is nothing but filtering operation. So for performing filtering, what we are going to do is we are going to place a filter of size 3 by 3 on every part of the matrix. So here we are having a 7 by 7 matrix. So we are going to place the filter over the 7 by 7 matrix and I'm going to convolute it with the kernel of size 3 by 3. The filter size and the kernel size should match. So here 1 into minus 2 will be minus 2, 6 into 0 will be 0, 3 into 1 will be 3, 4 into 1 will be 4, 0 into 1 will be 0, 1 into 0 will be 0, 2 into 0 will be 0, 5 into 0 will be 0, and 3 into minus 1 will be minus 1. So the summation of this will be giving you 2. So this filter has extracted a feature of 2. So 2 is the feature we are extracted from this window. Similarly, the window was slided over the entire image. So like this. So this was the final last edge values, that is 124, 412, 644. So we are going to convolute with the same kernel, that is -201, 110, 00, -1. So if I'm going to convolute here, I am going to get like 1 into -2 will be -2, 2 into 0 will be 0, 4 into 1 will be 1, 4 into 1 will be 1, 1 into 1 will be 1, and 2 into 0 will be 0. 6 into 0 will be 0, 4 into 0 will be 0, 4 into -1 will be -4. The summation will be 3. So here the input image was of size 7 by 7 matrix. Here now the features are extracted, and this is called as the feature map, and the size of the feature map was only 5 by 5. So here the feature map size was reduced. So this is a input image, that is our cat's image, and I'm going to convolute it with the kernel of -101, -101, and -101, and it was the features of the input image was mapped like this. This is the feature map after convolution. So the convolution and max pooling operations are performed multiple times for extracting the features. So this is the difference between a traditional machine learning model and a deep learning model. In a traditional machine learning model, the input is given for a feature extraction module. In the feature extraction module, the features are extracted and it is given to the trained classifier, and we can classify the output. Whereas in the deep learning unit, the inputs are directly given to the trained classifier, because here we are going to have the convolutional neural network. The function of the convolutional neural network is that it will directly extract the features without any usage of external feature extraction module. So thus our work will be minimized and we'll be using less resources, and less computing resources is necessary, and data usage will be less here. So input will be trained directly and we'll be getting the classified output. So feature extraction we are done. So for feature map reduction, so for example, 7 by 7 was the original size of the feature map. Then we have, after convolution, in this example, it was reduced to 5 by 5. Now we are having a feature map of size 4 by 4. So still this feature map size was reduced into 2 by 2 by using max pooling. So here we are going to consider only 2 by 2 windows. So we are going to choose a 2 by 2 window, and there we are going to choose only the maximum number. Here we are using maximum pooling method for dimensionality reduction. So I'm going to choose the highest value, that is 20 here. And similarly in this window also 30 was the highest value. So rest of the values will be neglected. Similarly, without losing any useful information, we are going to reduce the data. So here also 34, 70, 100, 112 pixels are available. I am going to only consider this feature, that is 112. Similarly, in this 2 by 2 max pooling also, I am having 4, 25, 12 and 37. Out of all, 37 was the highest value. So I am going to consider my 37. So thus I am going to reduce my feature map from 4 by 4 to 2 by 2 in size. So putting all together, we are getting like this. So our input image, that will be classified into 3 channels. That is, we'll be having a feature matrix of 3 in terms of red channel, green channel, and blue channel. So this is the feature extraction unit. Here we have convolutional layers. So in the convolution, the function of the convolutional layer is to extract the features in the input image, like the edges, the eye, the nose, the ears, like that. The features of the cats are extracted by the convolutional layers. Then the features were reduced by using a pooling layer. Further, it was convoluted, and further it was for convolution means filtering and reducing the dimensions. And further, we are going to perform pooling, and pooling also reduces the layers. So multiple times we are going to perform this, and finally we are going to flatten it into a one-dimensional array. So the image was flattened. Finally, it was flattened into a one-dimensional array of values. Further, we are going to reduce the number of features by dropping out. So by dropping out some of the features, unnecessary features, without losing any important information, we are going to reduce the size. Then the fully connected layer will be classifying it as a cat. So conclusions. So machine learning algorithms learn data to find hidden relations, to make predictions, to interact with the world. A machine learning algorithm is as good as its input data, and a good model plus a bad data will be giving a bad results. So we have to give good data. Data was the basic of the machine learning models. So deep learning is making significant breakthroughs in speech recognition, in language processing, computer vision, control systems everywhere. So thank you. I completed my presentation.
Thank you very much for wonderful presentation on the topic machine learning.
Thank you, sir.
Now I
Hello, madam.
Hello, sir.
Madam, actually, I have one question. How you can
Uh,
handle how you can handle corrupted data, madam, in machine learning?
we are going to pre-process it, sir. We are going to pre-process it. So we can, for after pre-processing, we can correct it, and we can perform this one convolution, and we can classify.
Okay.
We can process.
How we can decide, madam? How we can decide this model is good or not?
That for that we have to look for the performance metrics, like we have to calculate the accuracy of the model, the sensitivity of the model, the specificity. We have F1 score like that, sir. So all these using the confusion matrix, if we are going to calculate, then we'll know, sir. The accuracy is high, then the model will be perfect, sir.
again I request all participants, please, if you have any query, come ahead. So thank you, Vikrant sir, for asking a question. Ma'am have answered it sincerely. Now I request the chief organizer of the series, Honorable Principal M. Ambedkar sir. So please come ahead and have some words for today's session. You are welcome, sir. Thank you very much, sir. Now I move towards the vote of thanks. Shri Kumarswami Mahavidyalaya Ausa, District Latur, organized World Record Series 2. Today we have completed 187th session of the series, and the topic for today's presentation was machine learning, which have been presented by Honorable REKHA Madam. Sincerely, clearly covered all those details, all those aspects regarding the topic. As we know, the machine learning is an umbrella term for solving the problems for which development of algorithms by human programmers would be cost prohibitive, and instead the problems are solved by helping machines discover their own algorithms. Now this is a short definition, as madam have said sincerely, where madam have described all those points, types of machine learning, different steps to solve a problem, then data gathering, data pre-processing, then features of engineering, algorithm selections and trainings. Now these points have covered in a lecture clearly. Madam, really it was a very informative speech for us. So I'm very, very thankful to you. Then I thanks to the chief organizer of the series, Honorable Principal M. Bedkar sir, and thanks to the colleagues of the college, from my college, Dr. Sanjay Kale sir, Dr. Anita Dole madam, Vocational Supervisor Praveen Udge sir, and all others. Thanks to Vikrant sir, who asked the nice query in the series. So thanks to you, and heartily thanks all those dear participants for being with us every day, join the regularly on time. So I'm very, very thankful to you also. Now I request to you all, please fill the feedback link which is given in the chat box. So with the kind permission of the chief organizer, I declare that today's session is over here. Thank you, Rekha madam, once again for paying your valuable time. Thank you very much.
Prashant sir.
You can leave, madam. No problem. You can leave and take.